Okay guys, we're going to start on the inside cylinder of the old CNC head. I don't think it's going to need a whole lot of work because according to the owner, these were the inside ports made much better power. And we went over, this would be like the good port in a big block Chevy. This would be like the bad port in a big block Chevy. Okay, because of the way they go into the chamber. I do think it's very interesting that our liquid flow is very similar in the chamber itself to what we had on this side. This side I didn't quite spray enough, but you could see which direction it was going. And it is on the other side of the bowl, right? It's on the straighter side of the bowl. Let's do the stick through the port trick. Okay, I'm going to try to do this one-handed. Not easy. Okay. Alright, we have the stick going through the port, laying right on the short side. And you can see our liquid flow kind of follows that. We do have a nice amount of liquid on the other side. Let's take a look at the chamber. I should have said the bore. Alright, it looks pretty good. Not exactly the same as the other one, but not bad considering the only thing that's been done to this is I had to put a valve job on it because it wouldn't seal. I think that's it. The liquid flow on the valve is not great, but I think with some airspeed work we could probably get that better. That is quite a bit thinner than what we've got on the bad port. Is it the end of the world? No, but I would like to get it a little bit thicker if I could. Okay, right down its throat, you can see we've got a bolt boss, and we do have a ground out bolt that's fitted to that. Not sure exactly what he's going to do with that, but I'm not going to be changing that much. I did test it with the bolt in. The bolt has some sealant at the end. Was it leaking? Of course it was leaking a little bit. There's no doubt about it. In order for it not to leak at all, it really needs to be completely sealed, which I'm not doing. Our liquid flow looks pretty good, actually, I mean, it's a big port. It is lazy in spots. But, like the owner said, this is the higher horsepower port. And if you look, this has a much tighter turn. I think I drew it on top. I think you can still see it. It's got a much steeper turn out for the short side radius. But it works better. Now, he did say I could open it up for the push rod because notice where the push rod is. It is right on top of it right now. Now, I'm going to take a look at my airspeeds and figure out whether I need to do that or not. Since it is the better port, it may not need that push rod popped out. I'm going to take a good look at that and figure it out. Alright, the short side radius is obviously my work. You can see the radius before the bottom cut going into the bowl, and then my light burr finish on the short side radius. It doesn't look like I polished it, which probably should be on the list of things to do. Okay, this is the short side on the outside port. Let's compare them. Okay, they shouldn't be the same because they enter the cylinder at a different angle. Okay? So I will change that a little bit if I think it needs to through the airspeeds. Okay, these are going to be the last flows that you saw on the outside is when I ground old body filler and baloney out of it. And got a good gain everywhere with a little bit bigger port. Okay, well, how do they compare with the port that just had a valve job and some short side radius work that is the better port? well, let me do my pluses and minuses here. Okay, I apologize for the scribble and mess. It really gave me a hard time getting flows out of this, partially due to a hot garage, partially due to incredibly bad guides. It made it a challenge. But let's see how we did. We got a minus, minus. We got a minus with noise. Minus, 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 minus. Minus at 750. Minus at 900. And minus at 1 inch. Okay. This one over here was 381 at 0.75. 400 and change at 0.9, 406 at 1. Now, I don't think they're going to run that high a lift, but it does give you an idea of the stability of the port. Right? We would like to see it keep going up as the valve lift goes up. That would be ideal. If it starts going down, you know it's really having trouble with the short side and it's starting to separate. Okay, let's take a look at... So overall, it's not bad, but it's not nearly as good as this one. I mean, you can see after 600, it stays with it pretty close to 600. After 600, this port just walks away from it. Okay, that would make a noticeable difference. Okay, all of our swirls for this port are negatives, which means the swirl is going around this way. Okay, it wasn't that way on this. We actually had our swirl going around the short side on this one, right? This was our negative direction. Most of these were in our positive direction. It's an important point. Even though we still have our liquid flow coming out this way, I'm not sure pluses and minuses mean anything with this because they're completely different designs. So let's not worry about that. We'll just worry about the numbers themselves, right? This was relatively low until actually it stayed low through the entire curve, really. Right? It was relatively low swirl port because the air is actually swirling in the wrong direction. This is swirling in the direction we like to think of as right? Like a small block Chevy or a big block Chevy good port. And it's got a decent curve, right? It's a little fast in the low lifts, and it's fine at the higher lifts. If it's 750 we're going to run it at, we have way more swirl than we even should have, to be honest. I'd like to knock that back quite a bit. And if I work on the airspeeds, that may happen. As far as our exhaust, the exhaust was a nightmare. I couldn't even get airspeeds on it. The bench was overheating, and the damn guide was sticking. So this is what you got, and this is what you're going to get. Okay? Let me find an older flow file of the outside exhaust port. Okay. Now, this exhaust port had some work done to it from me. I did the valve job, I did my radius, and I changed it a little bit here and there to get our airspeeds better than they were. This is what our airspeeds were after I did some work to them. And you can see the pluses and minuses on whatever we had before that. It's the latest one I could find. I would say that's probably where it is now. Unless I made a mistake, which of course is possible. So we compare it to what the exhaust is doing now. Remember, I did a valve job on this already, and I did my radius on this. The rest of the port is as the owner left it. Minus, 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 noise, 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 minus, 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 even with a pipe, minus, okay? So the other exhaust port is better. Now, are they the same exhaust port? I don't know. They're close, but I don't know if they're the same port. Okay, what I did is I just took my stick and I made a line from the guide to the center of the port just to get the angle of the port. Okay, let's see what that angle is and then move over to here. They're pretty close. Okay? They may not be identical, but they're pretty close. So that exhaust port looks pretty close from one to the other one. As far as the bowl, this one has... it looks like I did do some work inside that bowl already. And this one I know I did work on. But I didn't do any work to the roof. You can still see the CNC lines. So I did the radius, I did the valve job, I did the radius, and I did part of the bowl work, which makes sense. Okay. Okay, the outer port, short side radius. Inner port, short side radius. It looks like I've done them both the same. Okay. All right, we're just going to go over our airspeeds on the intake. We don't have airspeeds on the exhaust, and it's not that big a deal because it's done a lot more than I thought I did. But what's interesting on our push rod pinch, top is completely dead. Now, after I did work on the other one, that push rod pinch cleaned up quite well. Let's get some of the outer numbers up. Okay, those bottom numbers are our numbers for our ground out port. And this is where we are here. Big difference, right? You could have, these were quite even. Very happy with those. Not great here. Okay, so this could use some work. The roof numbers improved quite a bit. It was also moving a lot more air, right? Those were measured at 750. These are measured at 750. That roof is pretty slow. And our short side was nice and even from side to side, a little fast in the center, but I think we can live with it. What do we got here? Really not that bad. It's a little bit faster all around. Right? A little bit faster in the center, a little bit faster top to bottom. It's not that far off side to side. So I think that'll just take a little work and we'll get that a little bit better. I don't think I'm going to waste the whole life on this because I think I put enough hours into these already. It was really the outer ports that needed a lot more work. And I'm pretty happy with the way those are set up now. After he runs those numbers through the program, I'm going to say on a 500 cubic inch motor, I'm going to take a wild guess and say with those kind of flows, 381 at 750, should be able to get almost 1,000 horsepower out of that. Not bad for a street mill. Have fun putting that on the ground, but you know, that's different. That's a different thing. Guys love the big numbers for bragging rights, which is fine. I got no problem with it. But I think that's one of the problems with the new cars that make a lot of power and the reputation they have about crashing. Tough to put that much power to the ground safely. All right, guys. I think we did enough on this for now. Thanks for hanging out. Have a good night. I did forget to show you this view, which really is not bad. I like how much we've got on the other side of that guide. Right? And I think a lot of this is just going to get cleaned up. Maybe get some of that body filler out of there that we don't need. And send it. Thanks, guys.